All right, let's quickly go back to first two slides and see what this section is about. All right, system of linear equations. You expect to see two equations, one on the top, one on the bottom, like this example here. And there are two variables there, x and y. Your task is get x as a number, y as a number, okay? And sometimes it will have a unique solution, one dot, one x and y coordinate you are going to get. Sometimes you will never get any solution, no solutions. And rarely sometimes you may get infinitely many solutions. Let's see in our homework sets which cases happen, but 90% of the time you will end up with one unique solution. And there are two methods you can apply to solve, okay? And on computer you're free to use either one, but on a paper test you need to go with the method it's mentioned here to get partial credit, okay, to get credit actually. It says substitution method, don't use the next method I'm gonna give you next, okay? Here is the substitution method. We will follow this recipe here, steps, and get x all isolated and the other side number, y is isolated and the other side as a number. And we will put those numbers in here, okay? All right, how do we do this? Step one, you're free to choose one of the variables, any variable from any equation. You get to pick this. There are four options. You can go with this, that, 3x, 4y. You have four, pick anything. Hint, go with the variable which has least number in front, or no number at all. That's easiest. So which one is most convenient then? X. This has double y. I mean, because we are going to isolate it, you're going to get rid of 2. It has an extra step. This has an extra step, 3x, and this has an extra step, 4y. So my target is this one. I like this x. It has nothing in front. It's easy to isolate. Okay? So I'll pick the first equation and first variable. And I'm going to isolate it. Take that equation. And isolate x. So isolating x means everything besides x must travel to the other side. So I need to send 2y to the other side as, can I just take a shortcut and say it? What is it? Minus 2y and positive 14. Just move this guy to this side. Flip sign. Flip sign. Okay? Next, we're done with step one. I isolated it and we're done. Frame this thing. This is your step one result. We are going to use this where? In the other equation you haven't used yet. So I used this one. I haven't used the other one. This is the other equation they mentioned. Other equation. And I'm going to use this in here. How? By substitution. Everywhere I see this variable, you see it's alone. I need to make this variable everywhere in the second equation with this guy, minus 2x plus 14. Every x will be substituted by this guy. All right? Let's do it. It's not 14. So all you need to do is don't touch y's, but x will take this form. So I'm going to move x and put this back. So watch what I am doing and criticize if you wish. Yeah. If you remove one item and bring back two or more items, look, I have two items here. You need to keep a parenthesis if there is something multiplying that thing. There was a multiplier 3, so it's a multiplier of both items. It needs to be distributed later. Okay. As I said, I will distribute this. It's minus 6y plus 14. Is that so? No, 3 times 14. Let's falling for that trick anymore. Alright, what is next? Yeah, just do what it says here. We are actually starting. We substituted this. We are solving the resulting equation. This was substitution, so step 2 is over here. We start solving it. Solve means isolate. Isolate the variable. Where is the variable? Y. There is a single variable here. It used to be 2 variables. This substitution eliminated 1 variable, and we ended up with single variable. We can solve it. Solve means isolate. And I need to first combine like terms. These are like, correct? What is minus 6 plus 4y? Minus 2y, right? 42. And getting y by itself means getting rid of minus 2 and 42. So I first divide both sides by 2. Is that right? No, 42 is first, of course. Cancel out. Now we divide both sides by 2. It's actually, this thing is minus 12. And now I'm dividing both sides by minus 2. Don't miss the minus. And we end up getting y will be 6, positive 6. Yay! We are halfway the solution. Why is it halfway? Where is the other half? X. You still need to figure out x. Okay, you found y. How do I get x? Let's keep reading the steps. We solved the remaining equation. Now you found the value, right? You found a value for y. We did, which was 6. Yes, it was 6. And use it in equation in step 1. What equation? You actually have 3 options. That value 6 you obtain for y, you can use it in this equation here and get x. That's first option. This is second option. You can use 6 here and get x. But I don't like either one of these options. What's the best option? Where do you want to use it? Where else can you use it? It's here. Just when you compute x through using this equation, you only need to put 6 here and get multiplied by minus 2 and add 14. You got it. Here you need to solve for x. Divide both sides by 3, take the 6 to the other side, etc., etc. A lot of more work. Not a lot, but more work. I like this better. So what I'm going to do is I will take this 6 here and supply in y and get this x in 2 steps. Multiplied by minus 2, which is minus 12, add 14, and voila. How do we write the solution set? Solution set will be a pair of coordinates. First coordinate is for x, the second coordinate will be y, and the problem is over. Are we good? Are we good? That's called substitution method because we isolated one variable and substituted back into the other equation. Substitution method. What was that x value?
2.
What? 2. 6. Thank you. All right. Coming up next, we will try the other method called addition method. You see it says addition method. Here are the new steps. It looks like we have more steps here, right? It's not that bad. I call both methods about the same difficulty, so I don't recommend either one over the other one. They are even. So what do we do here? First off, you need to prep your question. You can't just jump in and solve it. You need to prepare it. What is that preparation step? Here, this one. You need to get x and y, look, both x and y should be appearing on the left side. Do we have x and y appearing on the left side here? No, I need to get this guy to the left. And we need to also clear all parentheses. We still do it here. I'll do it. You can do it in step 2 as well, if I want to add. But I need to clear parentheses because in this form there is no parentheses. Look, no parentheses. So I need to multiply this out as well. This is prep step. And bring this y to the left side as well. These are the steps I'm going to take in step 1. Is it clear? Again, x and y's must be on the left, so I'm moving this guy left, this guy left. Besides, no parentheses allowed. All x and y should be clear. I will distribute this and combine y's as well because there will be some new y's popping up here. And hence, we will have this new and improved system of equations. 2y going to the left, it's going to make, it's minus 2y, minus, it's going to make plus 2y. 40 is just fine on the right side. Okay? Are we good? I'm doing these steps quickly, but are you okay? Let me know. Don't be shy. Raise hand and ask me, how did you get that 2y? I just added both sides 2y. That's how. Alright, this guy is gonna make, when you distribute 2x and minus 2y, right? 2x and minus 2y, but wait a second, there is a y traveling to this side as minus y underneath it, and they will combine into how many? How many y's do you have altogether? 3. Minus 3, 15 is just fine there. Make sense? Are we good? How did that happen again? 2 times y, 2y, 1 more traveling to left by subtracting y, and they will join in and make 3 of them. Now this question is ready for the remaining steps, right? Are they in standard form? Standard, standard. Perfect, right? Okay, what is next? It says optional, so you do this step if you see either a fraction or decimal. Do you see any fractions or decimals here? In case, hypothetically, I want to put this fraction here, how would you cure this? Like, I want to put here 2. There is a fraction now. How would you fix it? Right. If there is a number dividing one of your numbers and you want to get rid of it, you need to do opposite operation. Opposite of operation, division of 2 is opposite, is multiplication. You need to multiply entire left side and entire right side by 2. And this will be only 7. 2 will cancel with that 2, and this will be 4. This will be 80. So you need to multiply entire equation from left to right. But I'm glad there is no fractions. Decimals are the same way. If this was 7.5, to cancel that 0.5, what do you need to multiply that thing? To cancel, to make 7.5. This is a decimal. No decimal. What do you need to multiply entire equation with if this was 7.5? You can multiply by 2 because 7.5 times 2 is 15, right? That's the best option, I think, right? You can multiply by 4. You can multiply even by 10. But don't go overboard and multiply by 10, because it's going to make this 400 huge, inflated. But it's okay. It's correct. Still correct. You will just deal with big numbers. So multiplication is pretty much what's required here for decimals or fractions. Multiply. Guess what? Multiplication is also used in the next step. Okay, are we ready for the next step? Step 2 is clear. We don't need any extra multiplication. No fractions, no decimals. But step 3, we need to multiply one or both equations. Maybe both top and bottom may require this, depending on the need. Why? Why do we need to multiply them? We want to eliminate these variables by side adding, addition. So I will really take an addition line here, and I will add these guys line by line. You can do it side by side. However, the reason I'm doing this, so that these two things can match and cancel each other, like positive 3y and negative 3y could cancel it, but unfortunately, they don't have the opposite coefficients. This is just 2, this is minus 3. They don't eliminate each other. So how can we get this working? You have one weapon. Again, multiplication is one tool. You can do anything. You can use anytime you wish. By multiplying either the first or second or sometimes both equations, you can get these coefficients matching with opposite signs. Oppositeness is important. They need to be opposite so they can cancel. And you can do this for any pair of variables. You can do this for x's and y's. So you need to first pick a target. Who are you eliminating? Are you eliminating x's or y's? And circle them. Pick your target first. Which one you want to eliminate? Y's? You don't like y's? Good. So let's work on y's then. Is it wrong if I eliminate x's? No. It's fine. You can eliminate x's if you wish. Just I'm going with Austin's issue with y values. Okay? So 2 and minus 3. How can I get them matching? The only weapon you have is you can multiply top equation with a number. You can multiply bottom equation with a number of your choice, as long as that number is not 0. Don't multiply by 0, it wipes off everything. It's the bleach. It kills everything, okay? 0 is no good. We want them alive. All right. So what number do you think the top and bottom will multiply so they can meet?
3.
All right, say it one by one. Top equation. What do you want to multiply the top one with?
3.
3. This is what I do. It's kind of unofficial. I like to put parentheses like this and put 3 either to the right or left. Let's put to the left, 3. So that this means everybody gets this 3. Not only the first guy or second guy, but the last one. Every number in that equation must be multiplied by that number, 3. That's good. So I'm going to write the new equation here. So you need to restart your problem right here with the new and improved coefficients. 3 times 7 is 21x. 3 times 2 is 6y. And that simply equals 40. Correct? Of course not. It's 120. 3 goes into 40 and makes 120. Okay. That makes my initial number jumped into 6, but it's still not equal to minus 3. Why did you guys multiply by 3? It's not making minus 3. Now we need to work on minus 3 to make it 6. What do you think 3 needs to be multiplied so that it can make 6?
2.
Perfect. So I take another parenthesis for this guy and I'll put 2 this time. And this 2 goes into all 3 spots. 4x. minus 6y 30. New question. Now the difference is, look at this. Same coefficients, same 6 and 6 with opposite signs. If you add them side by side, 6y and minus 6y will eliminate each other, cancel each other, right? This is also called elimination method, addition method or elimination method. How about the other stuff? They will just join together. You add them, 21 plus 4 more makes 25. 120 plus 30, 150. And we solve for, by the way, where are we now? We added the equations. Now we are solving for the remaining variable. I need to solve for this. You see, there is only a single variable left, remaining, x. I need to get it all by itself, so for this we need to divide, right? Cancel and get x equals 6. Okay. Now I got half the solution, half the credit. How do I get y? Now you have 4 options. You can use the top equation if you wish, and use that x equals 6 here, option 1. Option 2, you can use this one and put 6 there. Option 3, you can use this one and put 6 there and solve for y, the third equation. And the last one is, you can use 6 here and get y from the last equation. Which one is the best choice? Which one? The last one? Okay. I might go with the first one. It looks simple enough, but not this one definitely. I don't like this because it has 2 y's and an x. This is a mess. This is, of course, the worst choice. It works, but worst. And you say this one. Okay, so I'm going to take that brand new equation here before the elimination and enter 6 in there. Take this 6 and put where? Right here. Okay? So we get 24 minus 6y equals 30. Subtract 24 from the other side, or both sides. Minus 6y equals 6. What is y? Y is negative 1. We got our pair figured out. Solution is a single solution. First coordinate x equals 6. The second coordinate y equals minus 1. This is our final answer. Okay? Okay? Question? Alright. I did this part. Now how about these 7 last steps? I always skip them. What is this steps for? Step 5, check the ordered pair. Step 5. Step 7, check the ordered pair. That means if you have time, it's kind of optional, but I strongly recommend it if you have time in the exam. But if you're doing on a computer, you'll be fine. You'll say incorrect or wrong. But in the exam, you need to check your solution and make sure it satisfies these equations. So you need to enter those found values in x and y and make sure these equations check out. It's optional for me, because you're watching 30 people are verifying my steps. But if you're on your own, especially in the exam, if you have time left, don't rush to submit the exam, just sit down and do that and see if you have any mistakes. If these are not checking out, that means you probably made a mistake somewhere. Mostly in this multiplication, you're making some mistakes. You forget to multiply this side, for example. Okay? Are we good? Number 4 is coming up next. You'll learn everything you need to know. Just we are looking for more challenging tricks. There is nothing new. Let's see what can be challenging about this question. First, it says using any method, so this is great, right? You can pick a method. So you choose. How many of you guys wants to use substitution? Raise hand. You don't like substitution method? How many of you guys want to use addition method? How many of you guys want to go home? Skip this. Okay, I get it. Okay, substitution method was more. I will do substitution then. Okay? Alright. So we need to recall step 1. You need to pick an equation and pick a variable and isolate it. That's it. Pick an equation, pick a variable and isolate it. Which equation, which variable? Top what? Which variable then?
Isolate the x.
X. Okay. Top x. We're going to get this x alone. I was gonna, if the choice was mine, I was gonna go with this because this is almost isolated. I would just divide both sides by 9. It's a little bit easier, not too much, a little bit. Okay, but I will still stick to your choice and let's eliminate x. I'm not eliminate, isolate x here. So I will just move this guy to right side first. Okay? Let's move -5 to the right. We get what? 5y plus 6. Agree? Perfect. Next, to eliminate x, I need to divide both sides by 3. That one. And I have it. X is 5/3y plus 6. Raise hand if you see any comments, if you want to make any comments or something. So I know who's talking. Yes? Right, here is a common mistake. When you're dividing both sides by a number, you don't just divide the first term, but the second term as well. This is a mistake. This should have been a 2. Put this under a frame, because we will come back and use this. Don't lose it. First, we will use it in the second equation, and then we will use it once you obtain y value. You will come back and use y value here in this equation. Okay. Now, next step is take this variable, and it says replace me. It screams replace me. Who? X needs to be replaced by this stuff. So I will go ahead and make each and every x that thing. Okay? So I'm doing it right here. Open a parenthesis because there's a bit 2 pieces coming in. 5/3 of y plus 2 equals 15y plus 5. And now, how many variables do you see? 1. Only y, right? X is gone. X is history. This is a equation of a single variable. You can get that variable solved by isolation procedure. You need to get y isolated. For this, you need to first get y's together. Before getting y's together, you need to clear all parentheses. So you need to multiply these two. All right, 9 times 5/3. When 9 goes into here, they cancel and becomes 3. So 3 times 5 is 15y. Do you want to see more details? Here. I multiplied 9 and 5/3 of y. How? 9 and 3 reduced, they canceled, and 3 and 5 made 15. There you go, okay? And I go ahead and multiply this 3 by 2 and make 6, right? 3 times 2 is 6. And I have 15y plus 5. Raise hand. Austin.
Isn't it 9 times 2?
Yeah. This 9 and 3 cancel when you were multiplying this, but when it comes to multiplying 2, 9 is back its original variable. 9 times 2 is not 6 anymore, it should be 18. Okay? Woohoo, something bad is coming up. Do you see that? Yes?
Won't the 15s cancel out when you have to move them over?
Mm-hmm. To isolate y's, you need to bring them together. So I need to move one of them to the other side. And I like to move this guy to the left. When you do that, as your friends pointed out, they all killed each other. And this is a great day. Take out your cell phones and take photos because we're just proving something magnificent here. We just proven 18 is equal to 5. Nobody will believe us, right? That means because this equation was nonsense, no, this pair. There is no, this means this is nonsense, of course, impossible. Impossible. So because of that, that means x and y can never be obtained from this equation. So this was actually a 2-second question, not 2 second, 2-minute question. Once you get something impossible, you go ahead and say, no solution. Okay? So you're lucky if you end up one of these situations because you don't have to proceed and get x or y solved. Let's make sure though. That was 4, right? The solution set is, so if there is no solution, we call it empty set, right? And it's called inconsistent, okay? And that's it, that's pretty much it. This is inconsistent system, impossible to happen. All right, let's go ahead. There is one more question. Now, which method do you want to use this time? You get to choose again. Why don't we do addition this time, right? But before doing addition method, is there any nasty number or expression you see you need to clear out, fix? Okay? Fraction. We have a fraction. We don't like fractions. It's hard. They are hard to handle. So I want to prep this question. I'm not going to touch the first one because first 2 steps. I want to remind you. First 2 steps is to get the equation in standard form and clearing any fractions and decimals. Are they already in standard form? Yeah, they are in standard form. All x and y's are on the left. But we have a fraction we don't like. I need to clear that out by multiplying something. What? 2. Multiply, multiply, multiply. And get a brand new set. The top won't change though. It's still the same thing. The bottom set is now double x. And what is 2 times 1 over 2? 1, right? It's just 1y or 2y. Wait a second, what just happened here? They are the same equations. They are those 2 lines, they look different, but with the magic, I proved that they are the same. So what just happened here then? This has happened. Those two lines overlapping now, they are on top of each other. So you have a single equation here, not two equations, single equation. These two turned out to be one. Then I already know before proceeding further, we have infinitely many solutions here. Everything you can think of is a solution. If you don't trust me, just try. For example, pick a number for x and y, I will prove it will satisfy both equations. No, you can't pick a one. I mean, pick something for x, I will come up with a y and it will satisfy. Pick something for x. 2, I say for y is 4. 2 times 2 is 4, 4 plus 4, 8. So every time you give me an x, I can give you a y, they will make 8, okay? So that means you can produce millions, billions, infinitely many solutions. All right, another reason is you want to eliminate them, right? If you still want to continue, you're not trusting me, you want to continue, you want to do elimination method, right? Addition, you need to get these numbers opposite, so you need to multiply one of them with a minus. Which one you want to put the multiply with the minus one? Top? Let's multiply with top. What happens? This becomes minus 2, that becomes positive minus y, correct? Minus 2x minus y equals minus 8. And positive 2x, positive y equals 8. Look what happens if you try to add them. When I add them side by side, you get nothing on the left, nothing on the right, 0 equals 0. Is this mathematically correct? Yes. It's not like this. This was something impossible. This 18 cannot be equal 5, but this is mathematically right, sound. So, but we are not getting x and y though. We eliminated everything. That because we have infinitely many solutions, and we say that those equations are dependent. They are related to each other. One is actually the same as the second one. So how do we answer this one then? Has infinitely many solutions, and the solutions are, the equations are dependent. Well, how do we write the solution set? It's entire x and y. I don't know how to do this part, really. Any ideas? Well, it has to be pairs, right? I mean, we need to enter, we can't do minus infinity to infinity. Is there a special button for this? How about we to check? Yes. Alright. How about we cheat? I can't cheat. What? Oh, no. Oh, they want it to, okay, I got it. Okay, they want it in set fielder notation. Now I need to try a new one. Okay, we know already this is infinitely many solution and the system is dependent. Check. Now, how do we write the equation? Okay, this part needs explanation. Unfortunately, my question switched a little bit. I will switch it. 2x minus y equals 6. X minus y equals 6 is your new question, okay? You just need to take one of the equations. I'm taking the top one, or you can take the bottom one, but I don't prefer the bottom one because it's a fraction. Forget this one. Take the top one, 2x minus y equals 6. You just need to write one variable in terms of the other one. So how? Isolate one. Oh, we already no, it was the previous question. So I need to isolate one of the variables. I will go with y. Y is almost alone. Bring this to the other side. And divide both sides with a -1, or multiply both sides by -1. Flip the signs. So this will be -6 and plus 2x. So this means every time you provide me an answer for number for x, y should be chosen depending on x as like this is 0, y will be minus 6, 1, y will be minus 4, 2, y will be minus 2. So y is depending on x. X is free to choose. So solutions are pair of x, y's, 2 coordinates. But anytime you give me x, I can compute y by this formula, minus 6 plus 2x. You're pretty much writing one of the equations here, y completely isolated. So we will try that. So you need to isolate y in either equation, top or bottom, and put it here. That's how you present it. All x, y pairs, but they are such that they are not random pairs. Y it should be equal 2x minus 6, or minus 6 plus 2x. If we switch spots, I hope the computer is that smart to understand it. Yeah, it's smart. But I like 2x first, minus 6 next. Can I go with the other option and say x is equal to y blah blah blah, like x equals 3 plus 1 over 2y? Yeah, that works as well. Try x equals, we'll put this other side. You just need to leave one of the variables alone, that's it. Okay? Another meaning of this solution set is everything on this line, look, this is a line equation with slope and intercept form, right? Every point on this line is a solution. It kind of verifies this demonstration. Everything on this line is a solution. It's not just a single solution or no solution, but everybody on it. So we are writing the entire line equation there as a solution. Got it? All right, right on time. We have 7 minutes. So. An application. The last one. Where do these equations pop up? Who builds their equation? They happen in real life. This is a one-word problem. You're going to build your own equations. So what's going on here? There is a boat. It moves up and north and south. It travels from north to south. But there is Gulf Stream current. That means when you were going north, stream pushes you faster. So your speed is faster when you're going north. When you're coming back to south, your speed is slower because you are against the current. Okay, have you ever paddled in the river against the current? You will know, okay? It's harder against the current. It's the same situation. Faster with the current, slower against the current. So you travel 1 hour with the current, but against the current is 3 hours. So you're more slower later. You're gonna find your boat speed and current speed. How fast is the Gulf Stream current is, how fast your boat is as well. Okay? All right, let's demonstrate this on a picture. Here's your boat. Okay? Now, you first travel north. And your stream is helping you. Stream is this direction. How much you travel, how long you travel north? How long? 1 hour, a total 23 miles in 1 hour. Right? And then you change your mind. You are coming back from north to south. How far? How far do you travel? 3 hours, 33 miles in 3 hours. Got it? Okay. Now in physics, we know that the distance you travel is what? Who knows physics? Come on. How do you compute the distance if you're moving with your car so many hours? What do you do? What?
Is it velocity over time?
Speed times time, right? Distance is speed times time. So how much did you travel here in this case? 23. What was your speed? Do you know your speed? No, it's the boat speed, boat, plus current. B stands for your boat speed, C stands for your current. They are together, they are in the same direction. Here, this is current, and your boat is opposite. So it's B plus C, and time, how far did you travel? How long did you travel? It was 1 hour, right? Here is your first equation. What is 1 times B plus C? Just 1B plus C. How about this guy? Your distance is 33. You traveled 3 hours, but what was your speed? What is your speed? It's not B plus C.
3B plus 3C.
What's that?
3B plus 3C.
It's not 3B plus 3C. Why are you adding both speed and current speed? Current speed is C. Both speed is B. Why are you adding them? Are they the same direction? You're against the current. So you subtract them. No. B minus C is your speed. Your boat speed is, your engine wants to go B miles per hour, but current is preventing it. It's slowing your total speed, right? And you multiply by 3. So you get 33 equals, multiply this, 3B minus 3C. So all together, I will pair this up now. I'm almost there. I'm not going to solve this. So all together, I'm going to put this in standard form. I like B and C on the left, 23 on the right. Can I flip this and make B plus C equals 23? Yes. You can flip both sides of the equation as long as you do it simultaneously. And this one too, I want to flip the sides. 3B minus 3C equals 23. Now you have a pair of equations. You don't like B and C? If you don't like B and C, you can make your own variables. Call both speed X, current speed Y. X, Y. Is this any different than this question? No. All you need to do here is, though, the meal was not ready. You cooked your own equations. And if you make mistakes here and minus mistake like you did, yeah, you're toasted. Okay, so you need to really model it right, then solve it. I will leave this to you, okay? I think you can do it. Yes, sir?
33.
Where's 33? Oh, it's 33. Sorry, thank you. This is 33. Thanks for
When I got off work, I was taking a nap. Yeah, I took a shower. Freaking working this sun. I need a shower. You know how much I smell like Rotten Tomatoes. Like, that's not sick. Oh yeah, I got a lot of tomatoes in the refrigerator if you want some. You don't like tomatoes? I don't like to eat them raw. They're fruit. But no, you don't eat a tomato raw.
Well, we're not doing
They're,
this to make
they are fruit.
that was.
Well, you can just cook one. I got like a whole